Welcome. This is the seventh lecture in the series Differentiation on R. You may remember in the last lecture, we did two cases of L'Hopital's rule. Today we are going to do the third case. And if you master these three cases, okay, any kind of L'Hopital's rule you can prove. Okay. They're all, in fact, it's a very meta exercise, very easy exercise. And I have given reference for that. Okay. So have it. And today we are going to play with it in the sense, the typical way I do in a class. Okay. Because in video lecture, I slightly do not completely do the way I do in a typical classroom. Okay. Because of recording various things. But today I decided to show how I do in the class and then make it rigorous. Okay. Get the idea of the proof first and then make it rigorous. Okay. Anyway, without much thing. But hopefully this will be a short lecture because the next lecture should be on Taylor's theorem. Okay, so I don't want to stop Taylor's theorem and stop halfway. Let us see, depending upon the time. Okay, let us share the screen. Yeah, as I said, this is the seventh lecture. So the theorem we want to prove is a L'Hopital's rule, the following version. So what is the following version we want to prove? Essentially, we want to prove something like this. Let me just write it loosely. We will limit x tends to infinity of fx by gx equal to limit x tends to infinity of f dash x by g dash x if this exists. Okay, assume this exists. Okay, limit x tends to infinity of f dash x by g dash x exists is equal to L. Okay, then I want to prove limit x tends to infinity of fx by gx exists and this. But what are the assumptions we want to do? This is how the form we want to make it infinity by infinity form, the so-called indeterminate form. So what does that mean? That means limit x tends to infinity of fx must be infinity. Limit x tends to the infinity of gx is also infinity. Okay. And what I know is limit x tends to infinity of f dash x by g dash x exists. It is equal to L. It's of course a real number. Okay. You understand? There are conditions we will impose. Don't worry about such things because most often you miss the wood for details. First, try to understand we are looking at infinity by infinity form as x tends to infinity. Limit x tends to infinity of fx by gx is of the form infinity by infinity. We want to say how to evaluate such limits. So assumption is limit x tends to infinity of f dash x by g dash x exists. It's equal to L, a real number. Then I want to say limit x tends to infinity of fx by gx equal to L. Is that clear? Okay. Keep that in mind. Don't worry. We will give a very rigorous proof. Okay. You will not be cheated. Okay. Right. So what I want to do. So let us do. This is what I want to do. Limit x tends to infinity of fx by gx equal to L, which is limit x tends to infinity of f dash x by g dash x. If you have gone through the earlier two cases of L'Hopital's rule, you know that the staple tool, the single most tool which we need for L'Hopital's rule is Cauchy's mean value theorem, right? So I want f dash x by g dash x. Therefore, I want here fx by gx. Therefore, obvious thing will be look at fx minus f of some r and gx minus g of r, where r is very large. Remember, because we are talking about limit x tends to infinity of fx, therefore I can take x to be very, very large. So fix an r which is very large. Let us look at this. By mean value theorem, I know this is of the form f dash c by g dash c, where r is less than c less than x. You understand this? Right. See, I'm not doing anything. I'm just playing with symbols, trying to understand, develop a proof. Okay, idea of a proof. Then we will give a rigorous proof. Okay, right. Now, as x goes to infinity, then c will also goes to infinity. Therefore, the right side will go to L. Is that clear? Right? Now, but then what do I want? I want fx by gx, whereas I have is fx minus fr by gx minus gr as x tends to infinity. You follow that? That won't do. So what should I do? Somehow I should eliminate this r term, fr by gr kind of thing. Okay, that is very easy. So what do I want? This is just a manipulation of symbols. 1 minus fr by fx by gx into 1 minus gr by gx. Again, don't worry. If I want to divide by fx should be non-zero, etc. But that can be arranged. If r is very far large, remember limit extends to infinity of fx is infinity. Therefore, for large r large enough, fx must actually be positive. Therefore, I can divide by this. Similarly, gx must be positive. Therefore, I can divide by gx. Therefore, r is so large so that this can happen. Okay. These are the r's which you have to fix carefully as towards the end. At present, don't worry about that. Okay, this is equal to f dash c by g dash c. Is that all right? Okay. Now, next thing is I have fx by gx, right? So, what I want is fx by gx into something. This something I will call as some name. Okay. This one, let me call it as I of x. This is equal to f dash c by g dash c. Okay. This object is I of x. Now, again, let us look at, see what happens. What do I know about this? R is fixed. Now x varies, x goes to infinity, and okay, therefore fr by fx will go to 0. Therefore, this fellow numerator will go to 1. And similarly, as x goes to infinity, okay, gr by gx will go to 0. Therefore, 1 minus gr by gx will go to 1. Therefore, algebra of finite limits, okay, the numerator goes to 1, denominator goes to 1. Therefore, limit x goes to infinity of psi x is 1. Do you understand this? Right? In other words, let us write fx by gx equal to f dash c by g dash c into phi of x, where phi of x equal to 1 by xi of x. You follow that? So, as x goes to infinity, this will go to L, this will go to 1. Therefore, I hope I have got the proof correct. Yeah. This is the basic idea of the proof. Now, we have to work with our epsilons and how to choose various r so that everything is proper. Do you understand this? Okay, most often, teachers are prepare well and they go through line by line proof. Okay, so you think the proof is extremely difficult. That's not the case. Once you understand, then you just have to do. So, P R P. Yeah, let me just see whether I started the resume the thing. Yeah, I resumed the recording because sometimes I do forget that too. Okay, right. Now, how to do these things? So now let's look at what are the things I need. Okay, I know this is less than L. Okay, to prove this, so let epsilon be given. So I want to prove the result rigorously. Okay, let epsilon be given. Then what do I know? I will have to choose an R sufficiently large so that f dash c minus g dash c for any R. Okay, c will be greater than R, right? Therefore, this by this should be some left side epsilon or epsilon by 2 because I made it two terms. You will see that why. Yeah. Okay. Now, why I have to make it rigorous is the following, because I have the right side f dash c by g dash c. What I want is fx minus L, sorry, fx by gx minus L. I want to say this is less than epsilon. You understand? But that is same as saying f dash c by g dash c into phi of x is, sorry, phi of x minus L is less than epsilon. Okay, just 1 second. There should be some easy way of doing this. I don't know why it's not doing. You understand? Now intuitively I know f dash c by g dash c minus L can be made less than epsilon in some sense, right? But there is a phi x, but I know phi x also goes to 1. Therefore, what do? Is I do again an algebra trick. F dash c by g dash c into, I can write it as phi x minus 1, right? Therefore, since I minused it, therefore it's going to be f dash c by g dash c minus L. Do you understand that? This object, whatever is here, is equal to this. So I have to make sure this is less than epsilon. But this will be less than or equal to f dash c by g dash c phi of x minus 1 plus mod f dash c by g dash c minus L. You follow that? Yeah. So this object equal to this object, that I want to break it into two parts. Now what can I do? Now I know this, I can make this less than epsilon by 2 and this less than epsilon by 2, right? Now notice that this is fixed, but this f dash c by g dash c has an obvious bound, because this shows f dash c by g dash c for c greater than or equal to r, okay, will be less than L plus epsilon by 2. Do you understand this? From this, I get f dash c by c dash c in modulus will be less than L times epsilon by 2. Therefore, this first thing, okay, will be less than L plus epsilon by 2 times mod phi x minus 1. But if x is again very large, then mod phi x minus 1 will be less than epsilon by 2 into this L plus epsilon by 2. Do you understand this? Okay. See, if you had seen many of my lectures and sequences and continuity, etc., you will see how I think. Okay. If don't jump, if you are coming for the first time here, you will be completely confused what I'm trying to do. Okay, let us. Do you understand this? Let's go there. So first thing is, let us look at, since fx goes to infinity, that is, let me say limit x goes to infinity of fx is infinity equal to limit x tends to infinity of gx, right? Right. Therefore, so first thing is, where is the function defined? Since I'm looking at only the behavior of x at infinity, as x becomes very, very large. Therefore, I can take my function to be defined on some interval a to infinity to r. Okay. What are the conditions I need? The conditions I need it, limit x tends to infinity of fx equal to infinity, also equal to limit x tends to infinity of gx. Okay. And second, I want to say limit fx by gx as x tends to infinity is limit x tends to infinity of f dash x by g dash x. So g dash x should, f dash x by g dash x should make sense. That means g dash x should be non-zero. Therefore, let me also assume for all x greater than a, g dash x is not equal to 0. This is to ensure f dash x by g dash x makes sense. See, this is how you should understand, not just like that. Okay. The third thing, what we understand, now our hypothesis, limit x tends to infinity of f dash x by g dash x equal to L. Of course, this is a real number. Okay, you can modify the proof as L goes to infinity also, if L is infinity. But anyway, is that clear? Then what do I want to claim? Theorem, then limit x tends to infinity of fx by gx equal to L. This is the theorem we want to prove. This is L'Hopital's rule 3. Is the statement clear? Okay. Now let's start with the proof. Okay. So as I first said, what we are going to assume is the following. Let epsilon be given, right? Then we want to invoke the 3, therefore choose, okay? There exists R2, choose R1, of course greater than A. Said that if x is greater than R1, mod f dash x by g dash x minus L is less than epsilon by 2. You know why I wanted epsilon by 2. Go through the proof to make sure this happens, right? Okay. Next, I choose an R2, assume greater than 1, R1, so that, okay, fx is positive and gx is also positive. Can I do that? This is possible because limit x tends to infinity of fx is infinity, right? Therefore, I can take for any given m, I can take oh, I'm sorry, so many disturbances today. Anyway, since limit x tends to infinity fx equal to infinity, therefore given m equal to 0, I know there exists some r, okay? So I can also say R2, which is greater than R1, so that fx is greater than 0. And similarly, there is another R, so that limit extension infinity, sorry, gx will also be greater than 0. So choose the maximum. So make sure that R2 is greater than R1. Do you understand this? Okay, you should not struggle with this kind of thing. Okay, unfortunately, basic inequalities, don't learn, students tend to have problem. Okay, yeah. Is that clear? Now, what do I want to do? Let's go back to my trick. My trick was I want to write fx minus f of r by gx minus g of r, right? And I also wanted to make sure that fr by fx is less than 1. Therefore, 1 minus this will be positive. This will also be 0. Okay, you follow that? Therefore, since ix is never 0, therefore phi x equal to 1 by psi x will make sense. Hmm? You follow this? Okay. I'm really worried. Okay. The way the mathematics and analysis start, students only know how to think linearly. Anyway, let us do that. Okay. So what I want to do, I choose R3 now, which is greater than R2, so that for all x greater than R3, gx is greater than g of R2 and fx is greater than f of R2. Again, how do I do that? Because limit x tends to infinity of gx is infinity. Therefore, if I take m equal to g of R2, okay, for sufficient large R, if x is greater than R, gx must be greater than g of R2. So that R I am choosing as R3 and greater than R2. Similarly for f, but choose maximum of those two things. Therefore, I get an R3, single R3, which is greater than R2, so that both these things happen. Okay, so this makes sure my g of R2 by g of x will be less than 1 if, and it's also less than 1 if x is greater than R3. Remember, x is greater than R3, R3 is greater than R2, R2 is greater than R1. Therefore, fx is positive, gx is positive, right? Therefore, this is a positive quantity. Now, g of R2 is less than g of x, therefore, it will be less than 1. Therefore, this inequality will be true. Similarly, for f of R2 by fx. Okay, right. You will see a well laid down proof in my article. So, at present, I want you to think like an analyst. Okay, you keep all the things and keep on doing and arrange this proof. Okay, is that clear? So I chose an R3 so that this happen. Okay, now Let's look at fx for x greater than r3. Let fx minus f of r2 by g of x minus g of r2. Okay. Now by Cauchy's mean value theorem, okay, I know there exists C so that R2 is less than C less than X, so that this is going to be f dash C by G dash C. You see that we got everything. In place of R2, R, I had R2 now. Is it okay now? Okay. So I have this, right? Okay. Now, as I did earlier, what will I do? I'll pull out fx outside in the numerator. Therefore, it's 1 minus f of R2 by f of x. And here, denominator also I'll do that. G of x into 1 minus g of R2 by g of x. That's equal to f dash of c by g dash of c. Do you understand this? Okay. Now, as I explained, this fellow is between 0 and 1. This guy is also 0 and 1. So, call this as I of x equal to 1 minus f of R2 by f of x by 1 minus g of R2 by g of x. Right? This is a positive quantity by positive quantity, so there is greater than 0. That's the first thing you should observe. Is that clear? Therefore, what I have on the left side, LHS, is nothing other than fx into gx by gx into xi of x equal to f dash of c by g dash of z for R2 less than, sorry, R3 less than c less than x. Did I write R2 or R3 here? R3. Is it all right? Okay. Therefore, I can, now xi is not 0 because 0, this, I do not know whether it's greater than 1, less than 1. I don't care. But it is positive, therefore, I can invert it. Therefore, fx gx equal to phi of x into f dash of c into g dash of c, where phi of x is 1 by psi of x. Why does it make sense? That's because of this assumption. Okay. So, right. Now, again, I do this algebraic manipulation, which I said. What do I want now? So, I want to estimate fx by gx minus L. This is what I want to estimate. But that is going to be, okay, phi of x into f dash of c by g dash of c minus L. I know how to estimate f dash c by g dash c minus L. You understand that? Yeah, because my c is greater than R3, R3 is greater than already R1. Therefore, f dash c by g dash c minus L in modulus will be less than epsilon by 2. You understand? And what do I know about phi x? Okay, that's all I have to look at. Now let us again look at phi x. Okay, I should have said it earlier, but let us look at phi x is 1 by xi x. And what is xi x? Xi x is 1 minus f of R2 by f of x, 1 minus g of R2 by g of x. Right? Now what do I know? As I said in the motivation, f of R2 by f of x, as x tends to infinity, this goes to 0. Because this is a finite number, f of x goes to infinity. Therefore, the numerator goes to 1, denominator goes to 1. Therefore, by algebra of finite limits, this goes to 1 as x goes to infinity. And therefore, it's reciprocal phi of x, again by algebra of limits. Right? If limit extends to a of fx equal to L, L is not 0, then 1 by 1 upon fx, limit extends to a of 1 upon fx will be 1 upon L. Right? Therefore, this also goes to 1 as x goes to infinity. Right? This goes to 1 as goes. And this fact implies this. Okay? So that's what I want to use. Therefore, fx by gx minus L is, I want to use this fact, phi of x minus 1 into f dash c by g dash c. Since I subtracted this, I have to add it. F dash c by g dash c minus L. Do you understand? This object is what I have rewritten. Okay. Therefore, by triangle inequality, this is less than or equal to phi of x minus 1 into modulus f dash c by g dash c plus modulus f dash c by g dash c minus L. You understood? Okay. Now remember, my x is greater than R3, R3 is greater than R2, R2 is greater than R1, and my x is greater than C, C is greater than R3. In particular, C is greater than R1. Therefore, f dash C by g dash C minus L is less than epsilon by 2. Right? This immediately implies, remember, I have an estimate for this now. Therefore, f dash C by g dash C equal to f dash C by g dash C minus L plus L. This is less than or equal to epsilon by 2 plus L. Yeah. So I understand f dash C by g dash C is less than epsilon plus L, L plus epsilon by 2. Do all of you understand this? Okay. Now let's go back to this. Therefore, mod fx by gx minus L is less than or equal to modulus phi x minus phi L 1 into L plus epsilon by 2 plus epsilon by 2. This is true for all x greater than R3. Yeah. But I want this to be less than epsilon by 2 now. How do I make sure? Since limit x goes to infinity of phi of x equal to 1, there is an R4 which is greater than R3, so that mod phi x minus 1 is less than epsilon by 2 into L plus epsilon by 2. Therefore, for all x greater than R4, I have fx minus gx minus L is less than epsilon by 2 plus epsilon by 2 equal to epsilon. So we have proved it. Yeah. Please don't get intimidated by what I said at the beginning, but this is the way one usually any analyst will work through. Just try to do various things, then write a rigorous proof. Now you can see all of a sudden you keep on saying R1, R2, R3, R4, and because of that this happened, because of this happens, etc. You complete the proof. Okay. So many students, sometimes even teachers with good memory, try to memorize the proof and line by line explain the proof. Okay. But that doesn't give you the confidence that you can work out the proof by yourself. You see that how I did? I simply started with this. Yeah. So it just showed me I can do it now. Right? This also I explained how I will do that. Okay. Whatever we did, this all we explained in terms of epsilon and R1, R2, R3, R4. Yeah. Okay. Let us stop sharing. So you, as I said, you should look at my article, which will be available in the MTTS site, which is given there. And please download and go through all these three cases are worked out. Apart from that, in my book, Ajit Kumar and Kumaresan, a basic course in real analysis, I had given another version of L'Hopital's rule. Okay, all forms. Okay, there are one-sided limits, all such things. Okay, and something x goes to plus or minus infinity, and your L may be infinity, and form 0 by 0 or infinity by infinity. There are so many things, but all those things, if you have done these three things, okay, you can do on your own. Okay, you should have confidence. How will you get the confidence? Very simple. Go through my earlier videos on sequences. You will see how to estimate things, right? And the second thing is you go through my video on limits. I think it's lecture number 7 on continuity. All right, various limits, how I deal with a unified way of looking at limits. Once you had understood, you will see all these things actually are very easy. Okay, the only analysis needed is Cauchy-Minimalist theorem on how to manipulate the inequalities. Yeah, I have courage, and these are the things you should never ever worry about remembering a proof. Please don't do that. Finally, you need only the result. Even that many of your teachers will not remember how it is proved. Okay, right? But it trains you to think analysis. It trains you how to estimate things properly. You should have some kind of a blueprint, some kind of an idea, strategy, and how to make the proof rigorous. This is what you have to learn. That is what is going to help you in future, not by simply memorizing and trying to. Because I'm sure no exam will ever ask you state and prove L'Hopital's rule of this particular form. They are not going to do that. Yeah. So then what is the purpose? The purpose is these things train us in analysis so that later thing we will learn much better. Okay. I hope you understand. Okay. I appreciate this. Thank you very much. If you like this video, please post your comments. Thank you very much.